Good morning and welcome to our second lesson on factors and roots. And we're going to focus this lesson on what's called multiplicity of roots. I love that word. It's one of my favorite math words, like multiplicity. It sounds like a game that you could play, like, oh, it's my birthday, we're going to play a game of multiplicity. I don't know, it just sounds like fun. Multiplicity of roots and writing specific functions that would have specific roots. And we're going to keep that fairly simple. We're not going to go into the hardest core problems on that. I'd like to begin with a recap of the functions from last class. I don't know why function is capitalized there, but now you will see that it is instantaneously fixed, the power of pause. Okay, so we're going to begin with a recap of the functions from last class. Last class, we finished off, at least we should have, finished off with graphing each of these functions. And what we'll do is we will pick some of these to graph and go over them. And you might have them still on your calculator if you were following along with your calculator. So what we did last class was we confirmed that everywhere that we said we had a root, the graph actually did cross the x-axis at those points. And here's the zeros the zeros or roots or x-intercepts from last class. And I did catch a typo. I had written 3x plus 4 here, and the original problem was 3x minus 4. So I'm sorry about that. In last class, we graphed each one of these and confirmed what our algebra told us about where the graph should cross the x-axis. And the graphing calculator showed us that, yes, they did. Now, what I want to draw your attention to, though, is this one here. When the same factor showed up twice, it did have an x-intercept at the point 2, 0, but it didn't actually cross the x-axis. It did what's called bouncing off the x-axis. I've often used the word like it touches the x-axis, but it doesn't cross, so it comes down and touches it. If you're looking at the scanned copies of the notes that are available on Teams, you'll notice that the notes use the word touches. I am in this lesson going to use the word bounces because I think it's a little bit more visual and students have an easier time with the word bounces. Now, here's the key idea. If a 0 appears twice, it means the graph bounces off the x-axis, and remember what the x-axis is, it's the horizontal axis, but does not cross. And so it does intercept in the sense that it's like on the x-axis, but then it turns around and it goes back off in the same direction it came in. It does not actually cross to the other side. Now, this is actually a little bit more broad. It's not just twice, but any even number of times. So it could be if the factor appears twice, or if the factor appears 4 times or 6 times or 8 times. I used to make a really big deal about that in my class, that it was an even number of times. But what I found is that a lot of students got confused with the odd and even number of like appearances of a factor versus the odd and even degree and what that meant. And it was just a little bit of an overuse of odd and even. And the truth is that the chances that you will see a factor appear more than twice is not that great. It does happen. It can happen, particularly if it's the only factor in the polynomial. So you could see something like x minus 3 to the 4th power. So you'd have the same factor appearing 4 times. If you need to see like something like this is what I think is what I just said out loud. That would be like seeing x minus 3 4 times. So you could see something like that, but it's not that common. It's actually fairly rare. And so in the interest of kind of trading one thing for another, I have traded off the precision of how I teach it, with it's like an even number of times, for better understanding of the foundational concepts. And then for those of you that go on in math where you might see the same factors appearing like six, I can't think of why you would ever see something appear 6 times, but where you might need that piece of information, you should be able to pick it up fairly easily, and certainly with the help of a graphing calculator, you would be like all set with that. Okay, so for the purposes of this class, if a 0 or if a factor appears twice, what it means is that the graph is going to bounce off the x-axis there, but it's not actually going to cross. So here is an example. So here's what the directions for something like this would say. The directions would say state the zeros and whether the graph crosses or bounces at that point or at those points. Notice that I am trying to change up the vocabulary. So sometimes I am saying x-intercept, sometimes I am saying root, and sometimes I am saying 0. And we do want to understand that those are all words for the same thing. So looking at this, we're going to tap into what we covered last class, which was that if you see the factor, you can just flip the sign. You don't have to go through, oh, the x-intercept or the 0 means that y is equal to 0, and you replace the 0 with, or the y with the 0, and then you set up your 4 separate equations and solve them all. It's just not necessary to do that much work all the time. So if I'm asked for the zeros, and I already have the y by itself, I'm welcome to just flip the sign. So it would be x plus 3 equals 0. And then you would do the opposite operation, which would be subtraction, which would give you x equals negative 3. Here you would do the same thing, and you would have x equals 4. Here you would have x equals negative 5. And then notice that you have the same factor appearing twice, which means you're going to have the same 0 appear twice. And then the second part of the question is state whether the graph crosses or bounces at that point. And typically I will accept this. If the factor only appears once, then it's going to cross, and you can just put the letter C for cross. Here, the x minus 4 or the 0 of x equals 4 appears only once, so it is going to cross. And here, the x plus 5 is appearing twice, which means you have the 0 of x equals negative 5 appearing twice, which means it's going to bounce. And you can simply put the letter B underneath that for bounces. So if you were to graph this, okay, we have 1, 2, 3, 1, 2, 3, what? Make sure, 1, 2, 3, 4. Okay, so we're not totally sure what the graph is doing per se, but we do know that at x equals negative 3, it's going to cross through the x-axis. Now, without doing more detail, I don't know if it's crossing like this way or if it's crossing this way. Okay, that I don't really know, but I do know that it's crossing. I know that it's going to cross at x equals 4, so we come over here, and it's going to cross at x equals 4, so it's actually going to cross to the other side. And then at x equals negative 5, it's bouncing, so it's going to bounce off the x-axis and then turn back around the way it came. It might be doing this way. In fact, I think that it is, or it could be like bouncing off this way, and it could be crossing in a different direction. But that's what we're trying to find out, is what's happening at these particular points. So does it bounce or does it cross? You don't have to draw anything out at all. So I'm going to give you a couple of practice problems. You're going to state what the zeros are, and then whether or not the graph crosses or bounces at that particular point. Okay, here are the problems, and the last one has actually been changed from what it is in the notes, so if you are following along with the notes, just note that I did change that. So here's what the directions might say. State the roots and whether the graph crosses or bounces at each. You may use a graphing calculator to check your answers. So I'm going to pause the video and let you guys work through those problems. We'll give about 5 minutes for you to do that. Some of them might require that you do use the graphing calculator, especially number 3. Number 3 is a bit of a curveball. Okay, so for those of you following along at home, here's how you might answer these. For the first one, we have x minus 3 is a factor, and so x equals positive 3 will be one of the roots. It appears twice, and so it's actually going to bounce off the x-axis because it appears twice. Then we have x plus 4. Well, that's going to turn into a root of x equals negative 4, and there's only one of them, so it's going to cross. And the last one, if you solve this for x, you would have add 1 and then divide by 2. So 1 divided by 2 is 1/2. It only shows up once, and so it will cross. So you have x equals 3 bounces, x equals negative 4 cross, x equals 1/2 cross. For the next one, these are 4 totally different factors. Each factor is only appearing once, and so all of them would cross. We would have x equals negative 3 crossing, x equals negative 1 crossing, x equals 4 crossing, and x equals 7 crossing. Now, for this next one, we'll start with the part that's easier. I have x plus 3 out here, so that's going to translate into a 0 of x equals negative 3. It only appears once, so I know it is going to cross. Now we get to the curveball. This is the curveball one. You have x minus 1, and it is showing up 3 times. And nowhere in this lesson did I mention what does it do if it shows up 3 times. If you think back to this here, it says if it appears twice, and I mentioned it's any even number of times, then it actually bounces. And the same property holds for odd because math is consistent. So if it appears once, it crosses. But if it appears any odd number of times, like 3 times or 5 times or whatever, it will also cross. And so because the x minus 1 appears an odd number of times, it appears 3 times, this actually will be a cross. If you have a graphing calculator, then you obviously can graph it and you'd be able to see that it does cross the x-axis at x equals 1. And you should have a graphing calculator because we're at that point. Next one here, this one might also throw you a little bit. So we have y equals, and then just remember that x plus 3 all squared means x plus 3 times x plus 3. So we're using the exponent there as a shorthand. So I would do do the easy part first. Whoa. Okay. If you have x plus 3 and it is appearing twice, then you know that the 0 root or x-intercept that goes with it is going to be x equals negative 3. And because it appears twice, it is going to bounce. And then don't forget this right here. This would be x is equal to 0. So you set each factor equal to 0. That one appears once, and so it crosses. Let's see if I can give you a better... Nope, apparently I can't. I was going to try to give you a better C. There it is. I'll give you a better C. So remember that math is consistent. So if the way you're finding your roots and your zeros is you set each factor equal to 0, then we're going to set each factor equal to 0, which in this case is just x equals 0. So last two kind of had a little bit of a twist in them to see if you could reason your way through them or figure out another way that you could answer the question. But in the event that you kind of came up dry, it's okay. All right, last skill is writing equations. So this is actually working backwards. So you can also work backwards because math is good like that. And we've done this before where we work a problem forward, you go backwards. If you add, to go backwards, you subtract. If you multiply, to go backwards, you divide. If you factor, to go backwards, you multiply. If you multiply, to go backwards, you factor. And so we have this idea of like going back and forth. So with the problems we've been doing, you've been given the function and asked to find the zeros, but you can also write a function given the zeros. So write a function given the zeros or roots or x-intercepts. And this is how teachers write problems for tests, is we want the answers to come out nice. So we start with the answer and then we work backwards to construct a problem that we will then ask students to solve. So for instance, if you had this, if you had x equals 3, x equals 4, and x equals 5, negative 5, sorry. -5, and you were asked to write a function that had those solutions or those x-intercepts, then you would start with y equals, and then you know that to get like x equals 3 out, here we got one here. If x equals 3 out, that it came from a factor of x minus 3. And so we would put in the factor of x minus 3 because we know that's going to give us the positive 3. If you have x equals 4 as one of the answers, that comes from having a factor of x minus 4. And then if you have x equals -5, that came from a factor of x plus 5. So now, there are actually an infinite number of functions that you could write that would have zeros at that spots. And that spots, oh good grief, at those spots. So that's why it says write a function that has the given zeros. If you were doing this at honors, or if you were doing this in college algebra, so if you've got an eye towards college algebra, it would give you something more specific. It would say write a function that has these zeros and also goes through a particular point, which we sort of did when we were writing parabolas. We said write a function with the given vertex and goes through a point. And the way you do that is you plug in the x and the y of the point and you solve for the leading coefficient. We're not going to do that with polynomials, but it is something that you've done before and it does extend to your higher order polynomials. Second example is write a function or write an equation with the zeros x equals 2 and x equals -7. So you'd start with y equals. A positive 2 came from a factor of x minus 2, and x minus 7 comes from a factor of x plus 7. This, as I mentioned before, this is what's called factored form, and you guys have spent a lot of time taking parabolas and putting them in factored form, but sometimes you'll be asked to actually multiply it through. And so you could be asked to multiply that through and given the function in what's called standard form. It's so much fun. And that's usually a directional thing. Okay, that is usually a directional thing. Last one of these examples, write a function with these zeros. X equals 3 and x equals -4 with multiplicity of, what did I say? With multiplicity of 3 is what it says in my notes. So finally we get to that vocab word back at the beginning. I said, I love the word multiplicity. It just sounds fun. Multiplicity just tells you how many times this zero appears. So if it says multiplicity of 1, it just means it appears once. Multiplicity of 2 means that it appears 2 times. And so multiplicity of 3 just means that this is going to appear 3 times. So you start off with y equals. A 0 or root or x-intercept of x equals 3 came from x minus 3. And then a 0 or root or x-intercept of -4 comes from x plus 4. And here's what the multiplicity of 3 means. It means that that appears 3 times. So that's how you interpret that. Now you could write it like this. Instead of writing x plus 4 times x plus 4 times x plus 4, you could write it with an exponent of 3 because that's what exponents mean. They mean repeated multiplication. All right, so I'm going to give you 3 practice problems to do out, and I'll give you some time to do them, and then we'll go over them in the video. Okay, so here they are. Write a function with these roots. X equals 4, x equals -5, and x equals -7. 2, x equals 3 with a multiplicity of 2. X equals -2 and x equals -10. And then the last one, x equals 1, and then kind of a slick one, x equals 1/2. So see if you're able to work backwards through that 1/2 deal and come up with the factors. We will pause the video at this time, and I will go through and explain it after the pause. Okay, so for this first one, you'd start with y equals. And again, I know several lessons ago, I had like polynomial equation versus polynomial function versus polynomial expression. If you go back to the videos, you'll see like what I did with that. So your function, you probably want to start off with either y equals or f of x equals. So this one, you should have x equals x minus 4, x plus 5, and x plus 7. Should be simple enough. You could multiply all that through, but I wouldn't unless I absolutely had to. Next one, y equals, x equals 3 comes from x minus 3, and that multiplicity of 2 means it shows up twice. And then you'd flip the sign, so you'd have x equals negative 2 becomes x plus 2, and this would become x plus 10. You could also write that with the squaring of the x minus 3, and that would probably be encouraged. So you would have x minus 3 all squared, x plus 2, x plus 10. Now for this last one, you have y equals, you're going to have x minus 1 because you'll flip the sign on the 1. Now you might write this, x minus 1/2. And technically that's right, but that's not really how we want you to write it. Probably the 1/2 came from add 1 and divide by 2. And so we're actually going to pull the little slide and divide little trick there and slide that back so that we get a nice factor that has integers in it. And if you were to take that 2x minus 1 and solve that, like you would add the 1 and then divide by 2, and that would give you the x of 1/2. But you'd want that to come from the factor of 2x minus 1, not the factor of like x minus 1/2. Like that's just a little bit weird. But it's kind of nice to see the slide and divide. Now you'll notice that in order to work with roots and factors, okay, we need the polynomials in factored form. But what if they're not in factored form? What if they are in standard form? That means that we need ways to be able to get higher order polynomials factored. So we're going to revisit factoring for a couple of days. We're going to cover 2 more special cases of factoring and get some more practice with the factoring if you felt like you didn't get it the first time. And then we're actually not going to go through using polynomial division to get stuff factored because we're going to keep it simple. We're going to pull all of this together, so your end behavior with your factors and your roots and your zeros, and to sketch simple graphs of polynomials, and then we'll do polynomial division, and then we'll go on to something totally different.